Hi there, and welcome to another college math video. In this video, we're going to begin our look at our unit on statistics. So for statistics, we certainly are going to look at quite a bit, I guess, of the nuts and bolts of actually doing some computations and talking about sampling techniques. But on the flip side, throughout everything that we do, I want to make sure that we're always thinking about the potential misuse of statistics, especially in today's world. Statistics and data are thrown at us on the regular, and often people take all of that information and assume that it must be true, that there can't be any flaw in a numerical analysis. And I want to show you throughout this chapter that that is definitely not always the case. So in this first video, we're going to start just to look at, on the back side of things, sampling techniques, basically how data is obtained. So our two objectives for this video: answer questions involving concepts and or definitions in statistics. We always need to get a little bit of the background, lay the framework with some definitions, and then identify the sampling technique used to obtain a sample. So some notes. A general definition for statistics: the art and science of gathering, analyzing, and making inferences or predictions from numerical information obtained in an experiment. Experiment is the broad term used, doesn't necessarily always mean what you think of when you think experiment, but that's just the general term that's used. So in general, statistics, the art and science of getting information, analyzing it, and then making predictions from it for the future. So under this umbrella of statistics, we look at two different types, at least in this class: descriptive and inferential statistics. Descriptive statistics are concerned with the collection, organization, and analysis of data. So this is kind of on the front end, getting the data, organizing it, and then analyzing it, simply looking at the numbers. Where inferential statistics kind of takes things a step further, this is concerned with making generalizations or predictions with this data. So descriptive looks at that number and or the information, maybe summarizes it, or something like that. Inferential wants you to say, okay, here's what happened, and here's what we think this means moving forward based on the information. So two different ways of looking at the data. We have a sample. This is a subset of a population used by statisticians to make predictions about a population. Anytime that we collect information, it's pretty rare for us to be able to collect information from every single person that we're trying to represent. So if any data is being collected and broadcast about the United States or the United States population, it's almost impossible to talk to every single person in the United States and collect information from them. And so when we talk about getting a sample, this is a subset of the population. So making decisions and maybe getting information from a certain number of people to represent the larger population at whole. Now, ideally, with any sample, we're getting an unbiased sample, which is our next definition. And this is a sample that is a small replica of the entire population with regard to any of these certain criteria: income, education, gender, race, religion, political affiliation, age, so on. The list goes on forever. So let's say we were talking about the United States. If we wanted to test or sample the United States for a certain type of data, it would be ideal if we could get an unbiased sample, a sample that kind of replicated but was maybe a smaller scale, all of these certain criteria, or maybe just one, depending on what it is the study we're looking at. So that's the first thing to keep in mind, is that whenever data is collected in order to be analyzed and then presented, we don't necessarily know if the population that was sampled is a good representation of the population that it is we're trying to talk about. If you really wanted to dive into some good larger studies out there, you could probably find that information, but in your general media, you aren't really going to be presented, here's how many people were surveyed, here's exactly what they looked like, here's what all the techniques were. So usually they're just trying to make you assume that the information was a good sample, an unbiased sample. But that's not always the case. So that's one of the first things to keep in mind when we think about data that's presented to us. So now we'll talk about sampling techniques. We're going to talk about 5 in this video, but the truth is, this is kind of a generality of 5. There are way more than 5 out there. If you took a full statistics class, you would talk about that more in depth, but even if you'd have to continue on farther into statistics to get into more of that stuff. And there's even, truthfully, kind of combinations of each of these 5. We're just getting the general overview on these 5. And there are ups and downs to each one. But the first thing that happens when anyone is going to collect data is first they have to see how they can sample the population. Can they get an unbiased sample? What does their sample look like? And then they have to decide on a technique in order to obtain that data. So one that can be used is random sampling. This is a sample is drawn in such a way that each time an item is selected, each item in the population has an equal chance of being selected. It's very difficult to get true random sampling. It typically is going to require a generator of some sort. It's very complicated to get true random sampling, but it can be done. So an example of this, for all the examples, I'm going to use things happening, data being collected at an Orlando City soccer game. So let's say people in randomly selected seats are studied to represent the viewers at the Orlando City soccer game that day. So the population we're trying to represent in this example and all the other examples is all viewers of the Orlando City soccer game that day. And one way we could do that is true random sampling, maybe a generator, pulling out a certain number of seats throughout the stadium for us to go talk to and obtain data from. Another example, another type of sampling would be systematic sampling. In systematic sampling, a sample is obtained by drawing every nth item. Nth specifically just means whatever number you want to place there. So in this example, studying every fifth person walking into Camping World Stadium to represent the viewers at the Orlando City soccer game that day. So it could be every 100th, could be every 50th, any number can get placed in there, but it's systematic if you are systematically counting and taking every certain person to collect data from. There's definitely ups and downs to this. What if every person in between the fifth and then 10th person has a totally different mindset than all these fifth people? There are perks and downsides to each one of these, but this is something that has to happen in order for anyone to collect data. First, a decision has to be made. Two more techniques. We have cluster sampling. This is a sample that consists of a random selection of groups or units. So an example of this would be studying all the people in a few different sections to represent the viewers at the Orlando City soccer game that day. So you can imagine if a generator were to give you all of a list of seats and people around the stadium, it would be pretty difficult if maybe you were just one person collecting data to get everywhere around the stadium the entire day to collect that information. So sometimes in the instance of time and money being a problem, cluster sampling is used, where instead here you would be going to a few selected sections and talking to everyone sitting in those sections. It would take you less time for traveling all around, and you might be able to collect the information faster because everyone's closer together. Another example of a technique that could be used is stratified sampling. This is when a population is divided into parts. Population is a loose term here. It could be any sort of data we're talking about. And then, or strata, you can call them. And then a random sample is taken from each strata. So one way to partition, let's say a population is based on gender, race, income, etc. For our example, let's say we looked at a few random people from each section to represent the viewers at the Orlando City soccer game that day. So we've broken the entire stadium down into sections, the sections that are, kind of little chunks where all the seats are, and then a few random people from each are selected. The perks of this are that it gives us an opportunity to talk to someone in each little strata, but it would be difficult for us to get to all those strata, where maybe true random sampling would give us certain people here, but there's always a downside. There's always something that we might miss. These two are the most similar and the place that I usually see the most mistakes. So we will talk again in more detail on the distinction between the two at the end of the video. And then the fifth technique that we're going to talk about here is convenience sampling. This uses data that's easily obtained. Sometimes we have no other choice than to just use convenience sampling. And so for our example here, this could be studying the first 100 people to enter the stadium to represent the viewers at the Orlando City soccer game that day. You can imagine if we were short on time and money, or if we couldn't go into the game and go into all those different sections, if we just stood outside and talked to the first 100 people to get there, we would certainly get some data, but it's hard to say if that data would represent everyone. So like I said, when data is presented to you, it's often the case that you're not told how the data was collected. And you may or may not also know how much data was collected. Those are two important things in knowing if the data is a good representation. So keep that in mind as you see any piece of data in the real world. Okay, so for our practice, all of the questions are going to be around collecting data from students at the University of Oxford. So I've got some information here. This is a university located in England. There are about 22,600 students there, 11,000 undergrads, and 10,500 postgraduates. It's a very competitive school. About 18,000 people apply for 3,200 undergraduate positions in 2015. 40% of the staff are of foreign countries. How interesting. And Oxford's research involves more than 70 departments, and they're ranked 6th in the world in the QS World Rankings for 2016. So this is just the background, the setup for all of the questions that I'm about to pose in the practice section. So there are going to be 5 presented, and you're going to identify which sampling technique is used for these 5. It's going to be all 5 of them used once, as you see in the list. Random, let's underline, systematic, cluster, stratified, and convenience. Those are your choices when it comes to the next slide. All right, so go ahead and pause the video, go through and see if you can identify which technique was used for each of these 5, and we'll go through them together in a moment. Okay, so let's see if we're on the same page. So the first one, 5 students are selected from each major offered at Oxford to participate in a survey. This one is stratified, and it's stratified because the population of Oxford has been divided into strata, in this case, majors, and we're talking to 5 students from each strata. So the population's broken into parts, and we talk to people from each group. The next one, the first 1,000 students admitted 1 year to Oxford are asked to answer survey questions. This is convenience. Anytime we're dealing with the first however many people, if it's a simple, quick way to get the information and then use it to represent your population, there's an element of convenience involved. The next one, every 15th person to register for classes at Oxford is asked to fill out a survey. Every 15th, this is your keyword, you have a number and an nth amount of people being surveyed. This is systematic. The next one, all students of Oxford University's names are written on paper, put in a bag, and 50 names are pulled from the bag to survey. This is as close to a description that I could get without using the word generator. This one is random. If they're all written on pieces of paper that are the same size and the bag is shuffled properly, each name should have an equal chance of being selected. In order for it to be truly random, you would have to have a true equal chance of being selected. You don't have that equal chance if you look at the second example, convenience. If you're not the first 1,000 students admitted, you're not going to see the survey. For the third one, if you're the 14th person in, you're not going to get talked to, and so you don't have an equal chance of being selected. For the first one, if certain people have been talked to in your major already, you don't have an equal chance of being selected as another participant. Which makes our last one, 20 random whole classes are surveyed, cluster. And this was a little tricky. This is one I often see mistakes on. This 5th one is often represented as random because the word random is in it. But remember, cluster takes our group and breaks it down into a partitioned sections, and then we talk to everyone from a few different sections. So we've talked to 20 whole classes to get information from them. And the classes were random. So once we break it down, it has to be that the clusters are chosen randomly. All right, so of these 5, the 2 that, even though random can sometimes get thrown in for confusion, the 2 that generally have the most confusion are definitely stratified and cluster. So let's take a bigger look at those, stratified versus cluster. In both techniques, the population, whatever that population might be, is divided into groups. So let's compare visually. We've partitioned, maybe it's 4, maybe it's more. Everyone fits into an area. These could be the same types of groups that we're breaking them apart into. If we're using stratified sampling, people are selected from each group to represent the population. So there'd be a few people here, a few people here, a few people here, and people here. Doesn't necessarily have to be the same amount taken from each group, but a representation of each group has to be made in some way, shape, or form. If you were to really go further in a statistics class, you might see a version of stratified that kind of followed the population of where people fell into these groups. For example, if you look at even within our United States government, how things are broken down, the country is partitioned into states. And so you've got two ways that that's represented. The House is represented based on our population. So each strata gets a certain number of people based on their population, where in the Senate, each state gets 2 people represented. So 2 different versions of stratified sampling, but both stratified sampling. Each partition has representation. Okay, versus cluster sampling, only a few groups are selected and everyone in those groups is looked at to represent the whole population. So maybe this circle and this circle. And maybe there's a bunch of circles and we only talk to 5 of them, but we talk to everyone here, and they're made to represent the entire population, every single circle that's represented. Those 2 are similar in that they have these partitions, but very different in how they deal with them. Stratified, we talk to a few people from each group, and in cluster, we talk to everyone from a few groups. Different ways of representing the information. Again, anytime you're seeing statistical data, the first thing that happened is that the information was collected in some way, shape, or form. Maybe it was using one of these 5 techniques, maybe a modified version of one of them, but the truth is you probably don't know, and you don't know if that was the right choice made for that type of data. If you continued on, you'd see a lot more about this, but that's one of the first things to keep in mind when you see any sort of piece of information. Always look at it kind of with the squinty eye. Well, how was that data actually collected? And usually, maybe sometimes you can find that out, but sometimes not. So these are good things to keep in mind as we then start to see the numbers and compute them. So I'll see you soon for another video.